Everyone, right? So we start
This call is now being recorded.
Okay, sorry. Sorry. Okay, so last week, right? So last week we already learned about the graph, okay? Displacement against time, right? So you already know there are many types of graph for displacement, right? And you already know that the gradient of the displacement against time, okay, is actually equals to the velocity. So it's equal to the velocity, right? So how you want to find the gradient? Okay, so for the graph, you have to draw a triangle first. Okay, so you draw a triangle. So let's say this is the graph. Okay, and then you draw a triangle. Okay, and then you plot. Right, you take 2 points here. So let's say this one is 0, 0. Okay, and then let's say this one is 5, 10. Let's say. Okay, and then you put y1 here. Okay, y1 here and x2, y2 here. Okay, x2, y2 here. And then you use the formula for the gradient. Okay, so m is equals to y2 minus y1 divide by x2 minus x1. Okay, and then you just put the value, okay, or y2 here, y1 here. So means 10 minus 0 divide by 5 minus 0, you will get 2. Okay, and then the next one, okay, the value is 2. Okay, and then the next one, how about the unit? So remember we learned on chapter 1, right? So if you want to find the gradient for the graph, okay, so you have to use the y-axis unit, right? Y-axis unit divide by x-axis unit. Okay, divide by x-axis unit. Okay, x-axis unit. Okay, so the y-axis unit, so where you want to get the y-axis unit? So this is the y-axis, so you get from here. Okay, this is the unit. Okay, and this is the symbol. So you have to know the differentiation. Okay, where which one is the symbol, which one is the unit. So usually at the back, okay, that one is the unit. So the unit here is meter. Okay, and then the x-axis unit here is second, right? So meter over second is ms negative 1. Okay, and also from chapter 1, we already know that ms negative 1 is the unit for what? Is the unit for velocity. Okay, so here we can conclude that actually the gradient of the graph displacement against time is equals to velocity. Okay, so there are many types of graphs, so I just discuss one here. Okay, and then we move on to the next graph. Okay, so in physics you have to remember there are three types, right? So the first one is displacement against time, the one that I just explained just now. Okay, and then the second one is the velocity against time. Okay, and then the third one is the acceleration against time. Okay, so from they are connected to each other. Okay, so let's say from the graph displacement against time, you can get velocity. Okay, and then from the graph of velocity, okay, the gradient, okay, that we will learn later, the gradient we can get acceleration. Okay, and then so that's connected, so they are connected to each other. Okay, so now we goes to the second graph, that is acceleration against time. Okay, all right. Okay, so this is the example. Okay, the first example of the graph velocity against time. Okay, so the first one is said here, the diagram shows the car move from rest. Okay, so mean if move from rest, u is 0. Okay, u is 0. Okay, and then after that when it move 1 second, it become 2 meter. Okay, after 1 second, it already moved 2 meter. And then after 2 seconds, it moved 8 meter. After 3 seconds, it moved 18 meter. After 4 seconds, it moved 32 meter. And then after 5 seconds, it moved 50 meter already. Okay, then we plot in the graph, we plot in the table here. Okay, so from the table here, after that, we can get velocity. So how you can get the velocity? Okay, so you already learned the formula, right? What is the formula for velocity? Anyone? What is the formula for velocity? We learn on
Displacement over time.
Yes, very good. Displacement over time. Okay. So from here, you already got the displacement, right? Okay, and you already got the time here. So you just can divide. So example for first one, S is 2, 1, T is 1. So the V is 2 ms negative 1. So you just put the value here, 2. Okay, so for this one, I want you to try to fill it first. Okay, then I will ask what is the value for V when T is equals to 2 and so on. Okay, so please try to calculate first. I already show one example here. Okay, and then after you already find the value, you can plot the graph here. So this one already plotted. Okay, when T is equals to 1, V is equals to 2. Okay. Okay, I give you like 2 minutes, okay, to plot the graph, okay, and then to find the value. So if you cannot understand how to plot and how to draw the graph, you can tell me. Okay, I will teach you. Okay, finish already? Can anyone give me the answer in the chat? Done. Right. So 2, 4, 6, 8, 10. 4, 6, 8, 10. Okay, so you can, yeah, correct, right? Because 8, when 8 divide by 2, you will get 4, right? Because S divide by T. Okay, very good. Okay, 8 divide by 2 is 4, and then 18 divide by 3 is 6. Okay, 32 divide by 4 is 8. Okay, 50 divide by 5 is 10. Okay, and then you plot the graph. Okay, and you plot the graph, you will get like this, right? And then you underline it. Okay, so let's say the question asks, okay, this is the example. Okay, let's say I just ask. Okay, all right, so what is the relationship of the graph? Anyone can tell me? Let's say the question asks, what is the relationship of the graph? Teacher, is a uniform velocity, right? No, this one is increasing velocity, uniform acceleration. Okay, this one is uniform. This one is not uniform velocity. If uniform velocity means the velocity is not changed. Okay, it's constant. Okay, let's say if the car move 8 meter per second, so all the way you move 8 meter per second. That one is uniform velocity. Okay, all right. And then for this one, okay, and then for this one, right? So what is the relationship? Right, yes, very good. Directly proportional. Okay. Okay, because when I mark your paper 3 that you submit to me on GC, right? Remember the assignment? I saw some of you, they put the relationship of the graph. The higher the time, the higher the velocity. Don't use that. Okay? Remember, if you use that, that one is wrong. Okay? For the relationship of graph, there are only 3 answers. The first one is directly proportional. The second one is increasing linearly. And then the third one is decreasing linearly. Okay, the one that you answer, the higher the V, the higher the T, the higher the V, that one is actually for physics, we call it as a hypothesis. Okay, that one is not the conclusion for the graph. Okay, so please remember, right? Okay, so this is the graph. Okay, so the next one asking you to calculate the gradient. Okay, so can you please help teacher to calculate the gradient? Okay, it seems that you calculate the gradient for displacement against time. The first you have to take 2 points, okay, and then draw the triangle, okay, and then you use the formula, okay, and you got the value of the gradient. Okay, so please try. It same like the one that I showed you before. Okay, for displacement against time. 2 meter per second. Okay, can you tell me what is the coordinate that you take? Okay, what's the point that you take for calculate the gradient? 10 and 5. You mean you take this one, right? Okay, you take this one, okay? And also 0, 0. Okay, so I put the round shape here, okay, because they already okay. And then we draw a triangle, very good. Okay, and then you read the coordinate here, 0, 0, and then this one, 5, 10. Okay, right. Remember, if gradient, must draw the triangle. Okay, and then next one, you have to use the formula. So what is the formula here? Y2 minus Y1, okay, divide by X2 minus X1. Teacher, do we have to put the formula every time we calculate something? Yes, please put the formula, okay? Please put the formula. Okay, and then let's say I said this one is xy, y1, this one is x2, y2. Okay, so 10 minus 0 divide by 5 minus 0. Okay, and then you will get 2. Okay, okay. So this is the gradient. Okay, and then for number 4, what is the unit? So remember, when we answer just now the graph for displacement against time, so teacher said what? If you want to find the unit for gradient, what you have to do? You have to divide, right? Y-axis unit divide by x-axis unit. Okay, so what is the y-axis unit? So this is y-axis unit. Yeah, very good. Okay, this one is x-axis unit. So how you want to find ms? Okay, I put here ms negative 1 divide by S. Okay, so the answer should be ms negative 2. Yes, very good. Okay, okay, ms negative 2. Remember, we learned chapter 1. Ms negative 2 is actually, what is the physical quantity for ms negative 2? Yes, very good. Okay, so acceleration. Acceleration. Wow, very good. But for those who are quiet like that, can you understand what teacher teach? Only the same people, right, give me the response. So other people, just try. It's okay if it's wrong, right? I mean, it's better it's wrong here than later you're wrong in the exam, right? So just answer. It's okay if you are wrong. Then if you are wrong, then I know that some of you still don't understand. Then I will teach again. Okay, so don't just keep it to yourself. Okay, and then the next one, number 6. Okay, what is the physical quantity showed by the unit? What is the physical? This one, the question is same, right? Number 5 and number 6. Okay, number 5 and number 6. Oh yeah, here, sorry. 6, this is 7. Sorry. Okay, and then the next one, okay, you have to calculate the area under the graph. So let's calculate area under the graph. So area under graph is where is this one. Okay, I shade for you. Okay. Okay. So this is the area under the graph. Can someone tell me what is the shape? What is the shape? This is called as what? Yeah, very good. Triangle. So remember what is the formula for triangle? Half times base times height. Okay, I'm sorry for my handwriting because I'm writing with my mouse. Okay. Right, the base here is 5, right? Okay. And then the weight the height here is 10. Okay. So what is the 2 5 25? Okay, how about the unit 35? This one you only calculate the value. Okay, and then the unit. So how you want to find the unit? Okay, so I half. Okay, so this is the constant, right? Half is the constant. So mean constant, they don't have any unit. So you can ignore it because it's a constant, it's a number. So number, we don't have a unit for it. So we just ignore the 1 over 2. So what we want is only base, right? Base. Okay, and then the height, right? Base time height. Okay, so what is the formula for base is S. What is the unit for base is, is meter. Is S, correct, S. Alright, and then the height is, the unit is M over S, correct? So I just cut it off, so only have meter here. Okay, can everyone understand how do I derive here? I got meter. Anyone want me to repeat? Right? So it's only meter times meter over second. So S and S, I will cut it off, so it only left meter here. Okay. So what is the quantity physical here? So this one is the answer. Okay. This one is the answer for number 6. Alright. So I will put the line here. Okay. So this one is for number 6. I'm afraid you are. Okay. And then for number 7, what is the quantity physical here? So M is actually the length, or the correct one, we use it as a displacement. Very good. Okay, can you understand? Anyone want to ask teacher anything? Okay, teacher, if I put the answer distance, is it correct? Okay, you have to remember the formula for velocity is actually displacement divided by time, right? So the graph is velocity, correct? The graph is velocity. So means you have to use displacement. If the graph said speed here, yes, you can put distance. Okay? Because distance is speed is distance divided by time. So you can put the quantity the physical quantity here is distance. But this one is velocity. You have to put displacement because velocity is displacement divided by time. Okay, so I hope you are clear. Alright. Okay. So what we can conclude here? Okay, what we can conclude here? So for velocity against time graph, the gradient is equals to acceleration. Okay, acceleration. Okay, and then the area under the graph, okay, is equals to displacement or is equals to distance. Okay, it depends on the graph. Okay, it depends on the graph. If velocity, then means displacement, and if a distance is if a speed is a distance. Okay, but there are certain time that you can find distance based from the graph velocity against time. So we see about that later. Okay, so anything you want to ask teacher? Okay, so this is the main point here that you have to remember. Okay, all right, so we move on to the next one. Okay, so we already learned the basic. Okay, the basic thing about velocity against time. What info we can get from velocity against time. All right, so now, okay, there are many types of the velocity against time. time, okay, 0. Okay, the assertion here is 0. Okay, and then how about the graph? Can you find area under graph? Sorry, someone called me just now. I'm using my phone, so the line got disconnected. Okay, because someone called. Okay, so is it okay? Can you hear me now? Yes, okay, sorry. All right. Okay, we go to the next, right, for this one. Okay, so object at rest. Okay, so object at rest. Okay, so means the object is not moving at all. Okay, it's not moving. So when it's not moving, is 0. Okay, so means the acceleration also should be 0, right? So you put 0 there. Okay, and then next one. Okay, this one, can you find area under the graph here? Is there any area under the graph? Right? Is there any area under the graph? No, right? So no area under the graph. Okay, so what you should put? You should put here 0. Okay, so you should put here 0. Okay, so means the object is at rest. It's a rest. Okay, or you can say it's because it's at rest. Okay, or you can say the object is not moving also can, right? Okay, for B. Okay, right. For B, yeah, someone asked me just now about the uniform velocity, right? So if the velocity is uniform, it should be the graph is like this. Okay, you can see from 0 to 2 seconds, okay, the velocity is 10 meter per second. So mean the velocity is constant, right? So how about the gradient? So how about the gradient? Okay, remember the gradient, you must have a triangle. So can I draw a triangle here? Is there any way that I can draw like this? Can I draw a triangle here? No. So mean if I can draw a triangle, means the gradient also 0, right? Because I already told the triangle is actually equals to the triangle. So if the triangle, you cannot form a triangle, means the triangle is 0, the triangle is 0, you cannot form a triangle. So means the gradient also 0, and the gradient is represented by acceleration, means the acceleration also 0. Okay, put 0 here. 0, right? Okay, and then how about the area under the graph? Okay, so what is the area under the graph here? What is the area? 10, 10 divide or 10 multiply by 2? 10 multiply by 2. Area under the graph, this one, right? This is the rectangle, right? So rectangle, length divide by width. So 10 multiply by 2. So you will get 20 meter. Okay, so this 20 meter is actually equals to displacement. So 20 meter also. Okay, this is 20. Okay, sorry. Alright, and then this object moving with uniform velocity, or you can say here the object move at 0 acceleration. 0 acceleration. Okay. 0 acceleration. Okay, anyone want to ask teacher about A and B before I move on to C and D? Okay, what the important things you have to remember? You draw a triangle. If you cannot draw a triangle, means the gradient is zero. So when the gradient is zero, gradient is actually represent acceleration. So when the gradient is zero, acceleration also zero. Okay. Okay, constant velocity. Okay, let's say you got this question. Okay, let's say it's asking you, describe the motion, okay, of the graph. Okay, so they give you graph velocity against time here, and then the graph is like this. Okay, the graph is like this, and they ask you describe the motion. Okay, so in the exam, okay, the accurate answer, okay, because this is a graph velocity against time. So what is you can get from this graph is acceleration, right? So it's better for you to describe the acceleration. Okay, so means the answer is zero acceleration. Teacher, if I put uniform velocity, yes, but that one will be like second answer. Okay, that one will be the second answer. That means it's a have a possibility that it will not be acceptable. Alright, because you know in exam that we discuss the possible answer. Okay, that we discuss the possible answer. So if let's say you give the answer uniform velocity, that one is depend on the teacher whether they want to accept or not. But the most accurate answer is actually zero acceleration. Okay, that is the first answer. Okay, are you clear about that? Okay, so means they if they give you graph displacement against time, so what you should describe, should describe about the velocity. Okay, if they give you graph displacement against time, so your answer should describe the velocity. If they give you velocity against time, the answer should be describe acceleration. Okay, so I hope you are clear about that. Okay, so how about this one? Okay, so the first one, what we should do, we should try to draw a triangle. So I will try to draw a triangle here. Okay, so let me draw. Okay, draw a triangle here. Okay, I draw the triangle. Okay, right. So when you draw a triangle, okay, you can see all the size of the triangle is same. Okay, all the size of triangle is same. Okay, so means if the size of triangle is same, okay, here you can see the side is same. Because this one I draw by using a mouse, you try to draw using the ruler, okay, very nicely on your graph. You can see all the triangle is same, all the size of the triangle is same. Okay, so when the size of triangle is same, means the gradient also same, because teacher said the gradient represent the triangle represent the gradient. Okay, the triangle represent the gradient. So size of triangle is same, means gradient also same. Okay, and we already know that when the gradient is same, the acceleration also should be same, because graph velocity against time, it gradient represent acceleration. So means gradient is constant. Okay, and then this one you have to calculate, right? So try to calculate the for teacher for the gradient. What is the value here using the gradient formula? Yes, very good. 6 ms negative 2. Okay, remember what you should do. The first one, you have to take 2 points. So I put a mark here. Okay, and then the next step, put the coordinate here. Okay, and then next step, draw the triangle. Already been drawn for you. And then the last step, what you have to do, you have to use the formula to calculate the gradient. So 18 minus 0 divide by 3 minus 0. So you got 6. Okay. Okay. So 6, what is the unit? ms negative 2. Okay. So, and then we already know the gradient represent the acceleration. So if the gradient is 6, so means the acceleration also should be 6 ms negative 2. Okay, 6mx negative 2. Okay, alright, so this one, the acceleration is 6ms negative 2. Okay, how about the area under the graph? Okay, so what is the area under the graph here? This is a triangle, right? So I shape it for you. Okay, please count for me the area under the triangle. This one, we use a triangle formula, half multiplied by base multiplied by height. 27 meter, good. Okay, so you put here 27 meter. Okay, and then what is the displacement here? Displacement is actually the area under the graph is equals to displacement. So mean the displacement is 27 meter. Okay, so remember the last question I asked you to describe the motion. This is the velocity against time. So the motion should describe the acceleration. Remember, I already draw for you the triangle. The triangle is same. So the triangle represent the gradient, means the gradient same, means the gradient same. The acceleration also should be same. Okay, so but we didn't put same acceleration. We put uniform acceleration. We replace the word of same by uniform. Are you clear about that? For acceleration. Okay, some of you put constant acceleration also can. Constant or uniform is same. Okay. Alright. Next one we go for D. Okay, wait, I change place first. Here is too noisy. Wait, wait. Sing. Wait for a moment. Sorry. Okay. So, any question for C part? Alright, good. Okay, we move on to the D. Okay, for D, okay, so you can see here the gradient. So remember the gradient must draw a triangle. So we draw a triangle here. For triangle, we draw a triangle, we draw the triangle, right? Okay, and then when you see the gradient here, the gradient is same since the size of triangle is same. Okay, so when the size of triangle is same, the gradient is same. So gradient represent the acceleration, right? So means this one, the gradient is constant. Okay, constant. Okay, so constant. Okay, and then the acceleration means is same, right? But this one, the graph is decreasing. Okay, so the graph is decreasing, right? So means the velocity is decreasing. So this one we call it as a uniform deceleration. Okay, since the graph is decreasing, the velocity is decreasing. This we call it as a uniform deceleration. Okay, so uniform because the gradient is constant. Okay, the gradient is constant. Okay, teacher, can we write negative? So which one? If you want to calculate the acceleration here, so let's say they give you a value here like 0.5, let's say, right? Okay, and then let's say is if you make it longer, this one will intercept anti-x-axis. This one is 50 example. Okay, so if you calculate, this one is y2 minus y1, right? Okay, so y2 minus y1, xy y1, x2 y2. So 0 minus 5. Okay, 0 minus 5 is equals to 5 minus 0, right? So you will get negative 1, right? So the gradient is negative 1. Yes, this one you have to put negative value. Okay, because this one is the deceleration. Okay, remember when we calculate for acceleration, if the positive, the positive of the A is positive value, this is acceleration. If the A is negative value, this one is deceleration. Okay, for calculation, yes, you have to put the negative sign. But for this one, if you ask to describe the motion, you just put in the word form. Okay, you just describe in words. Okay, no need to put the sign of negative. Yeah, negative gradient. Okay, but don't forget to put the unit. Is it clear, Kritika? Anything you want to ask, teacher? Yes, all right. Okay, right. For this one, I want you to try, okay, for 3A1, okay, until 4. Okay, and I will call someone to answer it. Okay, A only. Please do A only. Okay, I give you like 3 minutes, okay, to answer. Okay, so remember this one is the graph of velocity against time. So what is the important point you have to know here? Gradient is equals to y. Gradient is equals to acceleration. And then another thing you have to know, the area under the graph is equals to displacement. Okay, area under the graph. Okay, area under the graph, it doesn't mean you have to be triangle. Sometimes can be trapezium also. Okay, do you know what is the formula for trapezium? Yeah. Okay. So actually physics is more like maths. I think if you notice, right? Physics, they are more like maths. So actually physics and maths is like brother and sister. So you cannot like separate it. Okay. So if you want that you want to be a physician or something, okay, you have to be good at physics and at the same time you have to be good at maths. Okay, because physics usually the concept of physics, the one that we use the formula, all the type of formula we use, okay, they actually derive, okay, from the maths by using the differentiation or I'm sorry, this one they are quite noisy here because some of the SPM candidate already come out from the exam hall. Okay, can I call someone to answer? Mm, can I ask Ku Jiayu? You are Ku Jung Kang sister, is it? Sister or brother? Sister or brother? Sister, right. So your brother is good at physics, so you must be good too, right? Alright, so what's the answer for JK? 2ms negative 2. Okay, let's see is it correct or not. Okay, first what you have to do here, plot the, yeah, okay, and then read the coordinate here, 10, 20, and then this one is 0, 0. Okay, and then you use the formula. Okay, okay, so I put m here. Okay, I didn't put y2 minus y1 because I think you already know that. Okay, so xy, y1, x2, y2. Why teacher always put xy, y1, x2, y2? Because sometimes, okay, when you in exam, right, sometimes you miss, okay, you put the wrong value. Okay, so put here. So when you want to use, you already know. Okay, 0 minus 20 divide by 0 minus 10. Okay, so this one you will get negative 20 and divide by negative 10. So negative, negative 20 minus, 20 divide by 10, you will get 2. Okay, and then remember the unit for acceleration is ms negative 2. Very good, Jayu. Okay, so remember every time you calculate, put the unit. Okay, because starting from KSSM, okay, for paper 2 must have unit. Okay, but for KBSM means the last, the form 5 now that are taking the SPM now, is okay. For paper 2 they didn't put the unit, they still can get marks. Okay, but starting from you, right, the KSSM batch, you have to put the unit for paper 2. Okay, right, for KL we call another one, another people. So let's see, Lim Yu Min. Lim Yu Min. Okay, what's the answer? Lim Yu Min, are you here? Yes. So what's the answer, Yu Min? What is the answer? For KL. 0. KL is 0. Alright, so let's see whether KL is 0. Okay, plot here. So what's the coordinate here? 20, 10. Right? Okay. And then this one, because I put xy, y1 here. So this one, I just put x2, y2 here. Did you get the same coordinate as me, you mean? Did you get the same coordinate as me? Because I want KL, right? So K and L. So this part. Did you get the same coordinate as me? Yes. Okay. So let's try to use the formula. Y2 minus Y1. So means 10 minus 20. Okay. So 10 minus 20. Okay. Alright. Okay, 10 minus 20. Okay, and then the second one, 20 minus 10, right? X2 minus X1. 20 minus 10. How you can get 0? Oh. How you get 0? Can teacher know how you got 0? Negative 1, ms negative 2. Don't forget the unit. How do you get 0? How do you get 0? I go to count the L. Right, so LM. Yeah, LM is 0. Okay. Alright, so okay. So right, the next one for LM. So for LM, I will answer, okay, for this one. This one you cannot calculate the gradient, right? Okay. Because the gradient is 0 here, since you can form a triangle at LM. There is no way for you to draw the triangle at LM. Okay. So we cannot draw a triangle means the gradient is 0. So you just simply put here 0. Okay, but please put the unit also here. Alright. Okay, we move on to the next one, MN. So we call someone else. Someone I never heard their answer before. Hmm, this one, Rachel Chu Weng. I'm not sure because the name, because I'm using phone now. Can I call this call Rachel? So Rachel, what's your answer? Can I call with Rachel? Negative 2. Okay. Negative 2. Okay, Rachel said negative 2. Is it correct? So let's try. 30, 10. And this one is 40, negative 10. Alright. Okay, so I put xy, y1, x2, y2. Okay. So negative 10 minus 10. Okay, negative 10 minus 10. Right? Negative 10 minus, wait. Is that incorrectly? Negative 10 minus y2 minus y1, right? Yeah. Wait, negative 2, 40, negative 10. Okay, this one is 30, 10. So y2 minus y1, negative 10 minus 10. Okay, correct. Negative 10 minus 10 divide by 40 minus 30. Okay, so negative 20 minus 10. Sorry, negative 20 divide by 10. So you will get negative 2 ms negative 2. Okay, so that's the answer. Alright, so we move to the next part. Alright, so JK. So can I ask someone to answer my question? Okay, I said, what is the JK wasted motion? So remember, when you describe motion, use words. Okay, don't use the number to describe it. So what's the type of motion here? Negative 2 ms, negative 2. Oh my god. Constant acceleration. Okay, very good. So you put here constant acceleration. Okay. They say they didn't give you a value, right? They didn't give you the coordinate there. Okay, so what can you do? You can draw a triangle. So if you draw the triangle, like I teach you before, okay, let's say there's no value here, right? They didn't give you 20, 10, all the values not given. So what you can do, you just draw a triangle. So when you draw a triangle here, you can see all the size of triangle is same. So means the size of triangle is same, the gradient is same. The gradient is same means the gradient represent acceleration. Gradient same, acceleration same. So constant acceleration of uniform acceleration. Alright, very good. Alright, good, Tava. Okay, so next one KL. So I called another one Hongzhen. Is it correct? Hongzhen, is it? Hongzhen. Is it I pronounce it correctly? Hongzhen? Hongzhen. Are you here? Teacher, choose from 4S. Okay. Right. After this, I choose 4S. Where is Hongzhen? Hongzhen? Hugh Hongzhen. Sorry if I mistake pronounce your name. You can tell me, right? Yeah, sorry. Right. Sorry. What's your answer? Hongzhen. KL? What is KL? Yes, very good. Constant deceleration. Where is my wait? Okay. Constant constant deceleration. Okay, constant deceleration. Okay, and then for LM, okay, LM. Okay, I give Avinash. Okay, come. What's your answer, Avinash? LM. Yes, very good. Zero acceleration. Okay, last one I choose from for S also lah, right? Okay, let me see the name first. Okay, Eugene. What's the answer, Eugene, for MN? Eugene, are you here? Uniform acceleration. MN is uniform acceleration. Is it? You can see the negative here. Is it uniform acceleration? Uniform deceleration. Very good. Uniform deceleration. Okay. So can you understand now how to find the acceleration from the velocity against time graph? Any question you want to ask teacher before we stop, and I will give you exercise from tutorial. Okay, I will give you exercise for tutorial, right? Okay, so I will stay in the Google Meet here. So let's say if you have a question, you can log in back. Okay, I will be here. Okay, until 12:30. Okay, I will be here. I will be here until 12:30. Okay, so if you already understand, okay, you can leave the Google Meet. So if you have question, you can log in back. I will be here and you can ask me questions. Alright, is it okay? Teacher exercise in form or no, no, no. It's in tutorial. I give you the tutorial, right? Tutorial 2.2. Yeah, this one. Wait, I show you. Wait. This one. Yeah, this one. You have it, right? So can I give you the question now? Okay. So are you already prepared? Ready, prepare for the question that I will give? Wait. Not this one. Okay. All right. Question number 1, 2, 3. Okay. 1, 2, 3. Okay. And then 4, 5. All right. 6. Okay. 4, 5, 6. Okay. And then this one not yet. Tak ada. Tak, dia tak ni lagi tak diterangkan. Teacher, we only have to. Teacher, we don't have 2.2. If did you take the notes at the guard post? At the guard post, I already put 2.1 and 2.2. If you have the yeah. If you take the notes from the guard, I already put 2.1 and 2.2 together. But if you don't have, later I will upload. After this, I will straight up. I will go to this and upload. Okay. Okay. So 1, 2, 3, 6. Okay, and then another one. This one, the structure question number 1. Only that one. This one. Okay. This one. Okay. Teacher, for some weird reason, I have question 1, 2, and 7 onwards. 1, 2, 7, which it means what? 1, 2, 3, 6. We can 1, 2, 3, 6. Alright, like this. I will put in the group what's the question you need to do. Okay, it's easy for you. And then I will upload the question in the Google Classroom for tutorial. Risha, how come you have 1, 2, and 7? I don't have 3 and 6. What? Are you sure? Should be like all this, right, in one piece, right? Okay, never mind. I will put in the Google Classroom. You can refer to the Google Classroom. Is it okay? Alright, so when we discuss, you do it first. Okay, then we discuss tomorrow, right? We have tomorrow at 1 until 2:30, right? So 1 until 1:30, we discuss this tutorial, and then after that, we move on to the next topic. Okay? So thank you, class. Alright, so sorry for today. Okay? Right, bye-bye. Take care. I will be here until 12:30, right? So if you have question, you can log in.
Thank
Bye.
you, teacher.
Bye bye.